Good morning. Hello, everyone. Welcome to our robotics class, and this is week 13. So we are going to be continuing with our curriculum that we've been using in VEX Code. So it seems like you guys are getting the hang of it. I've received, I would say, most of your code. So hopefully everybody's having fun learning how to code robots. And we're moving pretty slow because I want to really just get you guys comfortable, and I know that not everybody has really worked with code. You know, if you've been here for a while, then obviously yes. If you're new, then no. But even just with the new coding program, right? So last year we used Coder Z, and it was similar with the blocks, but now the blocks may have been a little bit different. So we're just really getting comfortable with this program. We're taking it pretty slow. Hopefully, you're starting to understand what all of the different blocks actually do, right? You're learning how to work with them, how to connect them in your workspace and run your program. And you're just getting an overall pretty good comfort level working with this program. So this week we're going to move on. So last week, if you remember, we started with that Castle Crasher game, and you had to code your robot to pretty much move forward and crash into the first castle that was right in front of them. So great job doing that. And what we're going to be doing this week is learning how to actually turn our robot, right? So we learned how to make it go forward, but now we need to learn how to also make it turn. And so it can turn right or left. So I'm going to pull up the lesson and I'll go through it with you guys step by step, and I'll do it with you, and then you'll get the chance to do it at home. And there is another short quiz. So I don't know, there might be a quiz every week, but it's pretty much what you should be doing is taking notes. And then obviously you have this video that you can go back to. But there is no reason why anybody should fail these quizzes, unless you're just off in la la land and you're just not even paying attention at all. Then obviously you're just going to go into the quiz, mark some answers, and you're going to fail. And I really don't want that. These quizzes are meant to make your grade get higher because I give you the answers in the videos. You take notes, you have the video. I mean, why in the world? I don't understand how you could fail. And you're only allowed to take it once, right? Because fair is fair. I saw a few of you guys go in there, and I saw it that a second time because you could see the answers. It scores you right away. So you can't go in and then go mark all the answers. You had the notes, you had the video. You only get the one chance. So I take the first grade that comes in through the Google quiz thing that I send out. That's the score that I put in. So please make sure that you're focusing during the lesson. You're jotting down some notes. You're making sure that you're paying attention, so that way you don't fail, right? And everybody should get 100 on these quizzes. They're really easy. So there's only 2 questions this week on the quiz. So I'll be letting you know what they are, and you will be hearing the answers to them in this video during the lesson. Okay, so turning the robot. So we're going to need to knock over other castles in the Castle Crasher playground. And not all of them are straight ahead. Some of them are to the right, to the left. And so we have to figure out how to use our code to turn the robot. So the 2 new blocks that we're going to be introducing you to this week are the turn for block and the turn to heading block. So these are 2 new blocks that are inside of the code. So we'll be learning about the turn right or left block, which is right here, and then the turn to heading block. Okay, so those are our 2 new blocks that we will be using this week. And if you guys remember, I'll show you really quick the super cool thing. If you click on the little question mark and then you click on the block, it will tell you what it does. So for example, I clicked on the turn for block. It says it rotates the drivetrain for a given number of degrees. So it says choose which direction the drivetrain will turn, right or left. And then it says set how far the drivetrain will move by entering a number of degrees. And the turn 4 block can accept decimals, integers, or numeric blocks. So we're going to learn how to use that this week. So that'll be fun. Okay, so the first thing that you can do, so if you have your code from last week, that would be helpful. You could pull it up again. If you don't, you could easily recreate it again as well. So that would be helpful. So I'll just do an example. So I have a lot of your guys' code saved here, but you could do load from your device, and then you could pull up the code if you had it saved. If you didn't have it saved, then you can just, I'll put it up again on the video really quick, and then you guys can copy it. Okay, so I just quickly put the code back up. So if you remember the blocks that we had, the set drive velocity, you could set it anywhere from 0 to 100. And then you had the drive forward for 800 millimeters, drive reverse for 800 millimeters. So you're going to click in here and you're going to rename this. So this is lesson 3. So you could rename it. Put your name, please. So I know it's yours. Lesson number 3, and this is the turn block. So please make sure you rename it. So then that way, when you end up saving it and sending it to me, I'll know it's yours because it'll have your name on it. Okay. So we're kind of just starting where we left off. So it says the turn 4 block rotates the VR robot a given number of degrees. This example will have the VR robot drive forward to knock over the center building, reverse back to start, then turn and knock down the building in the bottom right-hand corner of the Castle Crusher. So what you did last time, you drove forward, knocked this robot down, drove backwards, back to start. Now this time it's going to turn to the right and drive forward and knock down the castle in the lower right-hand corner. So we're going to have to figure out how to do that. So it says to make a VR robot turn at different speeds, the turn velocity can be increased or decreased using the set turn velocity block. So again, it can be anywhere from 0 to 100. And remember, now we're talking about how fast it's turning. So we already used the set drive velocity block. So that was when you were just driving forward, how fast were you driving forward. So now think about like when you're in a car, right? And I know that nobody drives yet, but you drive in vehicles. So, you know, the person who's driving, they can accelerate, they can go faster. And then when they're going to make a turn, depending on if it's a very sharp turn, like a 90-degree right turn, or maybe you're just kind of turning, but it's a very gradual turn, your speed will be very different depending on that, right? And so you have to also think about this with the robot, because like, for example, if say you're making a very sharp turn, if you are speeding, you're going at the top speed and you're making a sharp turn, chances are you may end up just spinning out, right? Because your car, I'm talking about if you're in a car. But then if say you're like on a road and the road is just kind of turning, you can go a little bit faster because it's a gradual turn. So just kind of imagine how things work when you're moving, right? And think about your speed there. So just kind of getting you guys to think about the whole thing. So we can use the set turn velocity. So it says then you can drag the turn 4 block and you can attach it beneath the drive 4 block and set the parameters of the turn 4 block to turn right 90 degrees, okay? So your code will look something like this. You have your drive velocity, then you need to do your turn velocity. So you have to stick that in. So let's get a turn velocity block. You can easily stick it right in there. Okay. And then we can get a turn block. And we know it says we're going to turn right for 90 degrees. So it looks good. We could change our velocity to 100 if you want to make it match. Okay, so now this is what our code should look like. So hopefully everybody can see that. I'll make it a little bit bigger. So we have a when started, we're setting our velocities, we're driving forward, driving reverse, turning right. So we have all of our blocks correctly in there. Okay, so now it says after we drag, then we're going to drag the drive 4 block and attach it below the turn 4 block. And we're going to set the parameters to 700 millimeters. So we need another drive forward block, and we're going to be going 700 millimeters. So let's get a drive forward, and then let's change the millimeters to 700. So remember, they're telling you the distance here. They're telling you 700 millimeters to type it in. A lot of this code, it can end up being trial and error. So I know at some point in the future when you're trying to solve one of these puzzles and you don't have a guide where they're telling you everything to fill it in, you may have to do some trial and error where you type in something, you test out your code, oh, didn't go far enough, oh, let me try again. Or I went too far, let me change it, right? So that's something to think about when you're coding, right? So this is very basic, very easy. We're pretty much walking you through everything. Okay, so now it says select the playground button to launch the Castle Crasher playground if it's not already open. So hopefully you guys remember how to do that. Press playground, and then our Castle Crasher game should be open. Excuse me. And it is, so there it is. So now hopefully you guys can see it. There's our little robot, okay. So it says select the start button to test your project. So let's test her out and let's see what happens. So let's watch our robot. Hopefully you guys can see. Move it up a little bit. Okay, ready? Start. There goes our robot crashing in, going backwards, turning right, and crashing down the other castle. Woohoo! Looks like our robot is functioning. So it says, watch the VR robot drive forward and collide with the center building before reversing back to start. The robot turns right 90 degrees, drives forward, and collides with the building at the bottom right-hand corner, right? So let's move on. So it says, now we're going to learn about the turn to heading block. So I'll tell you guys what this does. So this block can be used to turn the VR robot. And the block turns the VR robot to a given clockwise heading between 0 and 359.9 degrees. When a VR robot collides with a castle, it may be knocked off course. The turn to heading block ensures the VR robot will turn to face the next castle no matter what previously happened. So that actually sounds pretty cool. It sounds like a pretty helpful block. So if you imagine a circle, right? And now we're imagining that this block can then turn our robot in any direction within the circle to be able to point at wherever another block is. So this example will have the VR robot move to knock over the center building, then turn and knock over the building in the bottom left corner on the Castle Crasher. So this time we're aiming to go to the middle and then go back and then go to the left. So what we have to do first is remove the bottom 2 blocks from the project. So we have to remove them. Because to remove blocks, you can grab and drag it back over here where the blocks are and it'll get rid of them, okay? So then what we're doing next is we're going to drag the turn to heading block and attach it beneath the drive 4 block and set the parameters of the turn to heading block to 270 degrees. So let me go find it. Turn to heading is right there. So we need to change our degrees, 270 degrees. So again, they're telling you what it is. So it's not always going to be like that. You may need to play around with the numbers there. And then we're going to attach a drive 4 block and make it 700 millimeters. So we're going to go right, drive forward, and make it 700 millimeters. Okay. So now your code should look something like this, which it does. And we're going to go back into the playground and let's see what happens. So let me open up the playground. Okay. We're going to run our code and let's see what happens with this code. So Oh, oops, sorry. There goes our robot forward and backwards, turning and knocking the castle down. So really it was interesting to see how it was doing pretty much the same thing that we had it do previously, except remember it was going to the right, except we were using a different block this time for it to actually do that. So it says, watch the VR robot move forward and collide with the center building before reversing back to start, and then turn to a heading of 270 degrees and drive forward to collide with the building on the left, right? So it was going to the building on the left. So mini challenge, it says the VR robot should collide with the middle building and the building on the top right. You will be given a project, but there is an error. Edit the project to solve the mini challenge. So let's see if we can actually solve the mini challenge. I wonder if you guys could figure it out. So do you think that you could code your robot to go forward, backwards, and then somehow knock this robot down? I mean, not this robot, this castle down. So let's take away these two blocks, okay? Because remember, this is our code that we're starting with, where we're going forward and then we're going backwards. But now the next thing that we want to do is we want to have it knock down the building on the top right. So I'm gonna, they actually give a little video to show this. So I'm gonna put the video on. And then I'll let you guys watch it, okay? And then we can try it. Okay, so does everybody see what happened there? It crashed through the middle one, it kept going, and then it turned and it crashed into the one in the top, right? In the top right. So this is what we want to be doing. So we're going forward for a longer distance. So it does actually give you the code. So let me pop it in really quick. Hang on. Okay, so what I did is I quickly loaded up this code that they gave us into the workspace here. So that way we could test it out. So this is what they gave us for the mini challenge. They gave us this. So a few things you might notice that are a little bit different from the code that we previously had is that we're driving forward for a longer amount of distance, right? This was 700 or 800, but now it's 1550. And why is that? Because if you look at the playground here, right, in the first part of the challenge, we were having the robot drive here to this castle in the middle. But now this time, the robot is still doing that, but it needs to also go forward until it gets here. So that way it can turn and then get to this castle in the upper right-hand corner. So you have to really kind of think, wow, so it's going a further distance straight, right? So hopefully that makes sense. Then once it reaches here, it's going to stop and it needs to turn right, drive forward again, and then not crash into this castle here. So if you look at the code, it looks like it's going to drive forward. Then they're saying turn right 180 degrees, drive forward 700 millimeters, turn right for 90 degrees. So what we can do is we can open the playground and we can test this out and see what happens if we followed the code. But remember, they said there was an error in it. So let me run it. So it's going forward, crashing into the first castle. Now it's turning 180 degrees and it's going back. So it's not going in the right direction. Because let's think about our turn here. It needs to turn 90 degrees, right? Because it's turning right. So we need to go in and fix this from 180. I think that was our mistake in the code, right? So remember, bugs or errors in our code, very common, very common. So people don't ever expect to code something and get your code correct the first time. It just doesn't happen. It's just not, it's not a goal that really you should be setting because it can be very tricky. And a lot of the times code is trial and error, like we were just saying. So if you have this expectation that every time you code something, you're just going to get it right the first time, it can be a little bit frustrating because you're going to need to keep testing it out, testing it out, testing it out. Guess what? It's a real job. So if you ever want to go into the field of computer science, and maybe you're somebody who like really enjoys finding mistakes and errors, you just love that, it's a real job. QA, quality assurance. These people are testing the apps, they're testing the games, and their entire job, it's a full-time job, is recording bugs in the code. And some people just love it. I mean, especially so a lot of people who like video games, they work as like video game testers, like QA video game people. And they go and they play the game all day. And the goal of them playing the game all day is to break the game. And every time they break the game, they have a log and they log the bug. They log the error in the code. And then the computer programmer goes in and they look at that long list, and every game has hundreds and thousands of bugs in its code. And the people have to go in, these computer programmers, they have to find the bugs, they have to fix the bugs, and then the quality assurance person has to go in again and retest it again. So these are real jobs, and not just for video games, but these are jobs for apps, every app that you use that, I mean, somebody has to test it, right? Do you honestly think that they just create the app and then that's it? It's like, oh, it's perfect. No. And if any of you guys have like phones and you notice they do updates a lot of the times, if you ever, it's pretty interesting, but if you ever go into, I can't really show you here with my phone unless, because we're not really together, my phone's very small, but if you go in, you can see when you do like an update, it'll tell you everything. It'll say like, this fixes bug issues with blah, blah, blah. And it'll say what the issues were and what it's fixing. And that's because why? Either somebody reported a bug, one of the QA people found a bug, and they went in and they fixed it. And now they have to do an update to it for it to actually take place on everybody's phone, right? And so it's a real job. So I'm just kind of helping you guys to just set the stage for you, you know, working with code, that just like we had that code and it said turn right 180 degrees, and then we're like, that didn't work. And now we're going to try 90. So let's open up our playground and let's see what happens with 90. Let's see if we reach our goal. Okay, so here we go. Robots going straight, continuing to go straight, turning, going straight up, knocking into the other castle. So it appears that with that minor change, the one error in the code, and now it has accomplished what we have set it out to do, right? So hopefully making sense. So what you're going to be sending me is this final code for the mini challenge, okay? So I'll be looking that you put in all of this code correctly, that all of your numbers are correct, and then you can test it out in the playground and make sure it works. But you should do the same thing that you've been doing, which you guys are getting to be experts at. You're doing file, save to your device, and then you're emailing this code to me so I can pull it up and I can check and make sure that you followed the directions and that you got to the correct code for this mini challenge, okay? What else did I want to tell you guys? Oh yeah, so the quiz this week is 2 questions. Which of the following is the best description of the turn 4 block? Hopefully you guys know what it does. It can move the VR robot left or right a specific amount of degrees, right? Like we just did that. We just did right 90. It can go left 90. What types of values can the turn to heading block not accept as parameters? So you remember the block that we previously used, the turn for heading one, it was back in the beginning here, this one. So it uses degrees. So what do you think we can put in there? Can we put in a numeric value? Yes, we can. Can we put in a decimal? Yes, we can. Can we put a word or a text into here? If I just was typing out 270, it will not recognize that. So no, that cannot go in there. An integer, yes, absolutely. So it's words or text cannot be used in this field. Okay, so hopefully you guys get both of those questions correct because I just went through and told you the answers. So that would kind of be proof that you completed the lesson. Because if you just go in and you didn't complete the lesson and you just click anything, then you're going to fail. And that will be very sad. So hopefully you don't do that. Okay, so I'll be looking out for your code that you will be sending me, this code for the mini challenge. And then I'll look out for your quiz, and that will be your assignment for week 13. Okay, have fun with this. Hopefully, it's starting to make sense. We're learning a lot of code here. We're building upon it every week, and it will get harder and harder. So that's just how it is, right? You know, you'll learn more of the blocks, you'll learn how to move the robot around, and then I will be actually testing you on, and I'll be giving you challenges, and I will not give you the answers to the code, and then you will have to play around, trial and error, and come up with the answer of how to actually code the robot. So that's what we're working towards. We're not there yet, so don't freak out or anything. Be like, oh my gosh, I have to code the robot on my own. No, you don't have to do that. Not yet. But my goal is that, yes, you will be doing that in the coming weeks and months. So that's why I really, really strongly urge you to pay attention and do these lessons every week where I give you the answers so that way you're comfortable using the code and then you can actually go and you're like, oh yeah, I know how to make the robot turn. Oh, I know how to do that. I can make it drive. And you have an understanding. Okay, so that's about it. So I'll see you guys next time. All right, bye guys.